Hello, and what we're looking at today is something that looks horrible, but it really is not that bad. And what is that? It's the derivatives of our inverse circular functions. Okay. In other words, if I'll write it here, if y is equal to sine negative 1x, what is dy by dx equal to? If y equals cos negative 1x, what's dy by dx equal to? And if y equals tan negative 1x, what is the gradient of that? Okay, and so I'll prove these in class, but I'll just tell them to you now. The derivative of sine negative 1x is just this. X squared. Okay, it's just that, and cos negative 1 is very similar to that, and if you think about the graph you'll see why, but it's just negative that one. So exactly the same, but just a negative version of that. And tan is the one that's a little bit different as usual. That is just 1 over 1 plus x squared. Okay, so they're your key ingredients. The things that you need to know. Also, more specifically, I'll just write down the more specific ones. Now, when you get different functions in there in place of x, so if you had 3x in there or something like that, or x on 3 or something, I'll give these to you, but you don't necessarily use them if you're good with the chain rule. So I'll just write these down as well. So if you've got y equals sine negative 1 x over a, the derivative of that turns out to be 1 over the square root of a squared minus x squared. Okay, so that's what happens to the a. Similarly, exactly the same for cos. What's that? Squared minus x squared. Okay, so exactly the same, and tan x over a. Just be careful here. This is quite different to the other ones. Is a over a squared plus x squared. Okay, so there are your three ones. So what I said before is that if you've got a function of that with a letter a, so this is all where a is just a real number. Okay, x over 3 was my example. If x is over 3, you could just use the chain rule, and that's how I do it, because I sort of get confused when trying to remember these. But they're your rules. If you want to have them written down, you can refer to them. That's nice and easy. So what I'll do now is some examples. So let's do this. So an example. Got y, let's just do what I just said, sine negative 1 of x over 3. Okay, so there's two ways to do it. You could either use that formula. So the formula says, in this case, a is equal to 3. Okay, because it's x over a, using those formulas I just said. So therefore, your derivative with respect to x is equal to 1 over the square root of a squared, so that'll be 9 minus x squared. And so there you go, and that's it. So that's really easy. If you don't remember these formulas, then the way you need to do this is by using the chain rule. And I'll just show you what that would look like. The chain rule would say that dy by dx, so that's just finished there, so I'll just put a line through that, is equal to the derivative of this, so that's 1 over square root of 1 minus, chain rule says just leave that as it is, so you'll have x over 3 squared, and then you need to multiply this whole thing by the derivative of what that's in there, so that's just multiplied by 1/3. And then you'd need to clean this up and remove, you'd get I'll just show you what I mean. You get 1 over, so I'll just put that 3 there, and in here you get 1 minus x squared over 9 equals 1 over 3. What I'll do is put them all over 9. Sorry, I didn't leave much room there. So that'll be 9 minus x squared. And that 9, if that comes out of here, that'll become a 3. So I'll just take that out. That disappears, and that's just 1 over 9 minus x squared. So you can see, if you can remember the formulas, that actually makes that a lot easier. But you can just get the same thing. If you can't remember the formula in one of your exams or something like that, you can still just use the chain rule on that, okay? So there you go. That's how that formula helps you out there. Okay, so let's do another example. Let's do cos -1 of 5x or something like that. Okay, y equals that. Again, using the formula. I'll just use the formula this time because it'll just save me a bit of time. What's a equal to here? Remember, the formula tells us it's x over a. Okay, so in this case, a is equal to 1/5. So let's have a look. Let's do this. So therefore, dy by dx is equal to, using the formula tells us is equal to -1 over square root of a squared, so 1 on 25, minus x squared. Okay, so you could leave it like that. You could take this 25 out. It's probably preferable. In fact, I'm pretty sure if you left that in the exam, you could lose a mark on it, so it's better to be careful here. So let's put that all over 25, so it'll be 1 minus, we're going to put it over 25, so 1 times that by 25x squared. So leave it like that. Let's take this 25 outside of here, and you get 1/5 outside the front if I get rid of that 25. And that 1/5 will just go to the top line as -5 over 1 minus 25x squared. Okay, so there's your answer there. Now, in this situation, it's actually easier to use the chain rule. Okay, so I'll just come down here. And what would happen if I use the chain rule? So just coming straight from that, I could just write dy by dx equals, derivative of the outside is -1 over the square root of 1 minus, and now we just leave that as it is, so it'll be 5x squared. Okay, so we've just used the chain rule. We've left it on the inside. We need to multiply by the derivative of what's inside. The derivative of what's inside is 5. Okay, and that's it, equals -5 over 1 minus 25x squared. Okay, so just recognize that using the chain rule here is faster. So when it looks like this, I would recommend you use the chain rule. If you go back to the previous example, so I think it was sine -1 of x over 3, it's less work if you can remember the rule. Okay, the formula. So that's just some little quick things there to know when my battery's about to run out. I better finish this video quickly. I wonder if I've got enough time to do one more example. I hope so. If the video stops, you know what happened. So one more example. Let's just do quickly tan -1 of x squared plus 1. Okay, 1 is equal to that. Okay, let's use the chain rule here. So we've got a function inside of a function. So I'm going to go a bit faster in this, don't want to run out of battery. Let u be the inside here, x squared plus 1. Therefore, we want to use the chain rule, we want to know what du dx is, and it's just 2x. And so we've got y equals tan -1 of u, and therefore the derivative of y with respect to u is equal to, what's the derivative of tan? That was 1 over 1 plus x squared, but u squared in this case, we've got u. So there we go. So therefore, the derivative of y with respect to x is equal to the derivative of y with respect to x, du equals dy by du is 1 over 1 plus u squared. Now I'm just going to start doing these a bit faster. U, what is u? U is x squared plus 1. X squared plus 1. And that is squared. Good. So I'm just substituting u back in straight away rather than taking another step. Times by du dx, which is just 2x. Okay, so 2x on the top line. I could just neaten that up. I might just leave it like that for now because of my battery, but you could expand that you get x4 and you get an x squared plus 2. Okay, so you could do that, but that's how you take the derivatives of inverse trig functions. And my video is about to, my battery's about to die. See you in the next video.